Now we start 8.1. 8.1 is about arc length. Instead of thinking about area under the curve, we will think about the length of the curve. Let's consider the length of the curve from this point to this point. Then our strategy will be similar to when we consider the area under the curve. So what we will do will be, we think about this time small line segment, which connects the endpoints like this. Then what happens here is because we know the length of this interval, we know delta x. And also by using the function value, we know this length. So delta yi. Then we have a right triangle. The hypotenuse can be calculated with delta x squared plus delta yi squared. And what we realize is when this subinterval length becomes very, very tiny, this hypotenuse is almost identical to the tangent line. So let's say this is xi star. Then this one can be written as square root of x squared plus f prime of delta, the xi star times delta x squared. So this one came from this f prime xi is the tangent line at xi, and then that is approximately delta y over delta x. So delta yi is approximately f prime of xi star times delta x. So instead of delta y, I am writing f prime xi star times delta x. Delta x is a common component, so we take that out. Then we have delta x squared times this one is delta x squared times 1. So we are taking this out. So 1 plus f prime xi star squared. So what we are getting is this one is something squared. So when we take square root is that becomes delta x. So that is 1 plus f prime of xi star squared times delta x. That is where the arc length formula came from. So let's suppose that f prime is continuous on the closed interval a, b, then the length of the curve y equals f of x between a and b is formulated as integration again, a to b, square root of 1 plus f prime of x squared dx. Basically, from this analysis, we are connecting that with the integration. Or we can write it down as a to b square root of 1 plus ty over dx squared dx. Okay, so this arc length formula must be remembered. The problem is find the length of the curve. So y equals 2x minus 3. So x is minus 3 to 2. That is the problem. This is a straight line. So if you want, then you can figure out the length of the curve by just drawing the triangle directly. But so is that enough? Did you copy? So what I was saying was this is a straight line. So we can just draw the straight line, and then we can just draw the right triangle directly and apply the Pythagorean formula. However, we learned the arc length formula, so we want to use arc length formula. The first thing we have to do is we have to differentiate the given function to apply that to this arc length formula. So dy over dx is 2, and the arc length was given as minus 3 to 2. So this region, and square root of 1 plus d, this one squared, so 2 squared dx. So that means minus 3 to 2 square root of 5 dx. So this is a square root of 5x from minus 3 to 2. So that is square root of 5 parenthesis 2 minus 3. So minus will make plus, and so this is 5. So that is 5 square root of 5. The second question is y equals square root of 2 minus x squared when x is between 0 and 1. Let's write y equals 2 minus x squared 1/2 power because we want to apply the power formula. So we bring down the power, and 2 minus x squared, the 1/2 minus 1, and this is a chain rule, so we have to differentiate this part and write down here, then that is minus 2x. So that is 1/2, 2 minus x squared. This is minus 1/2 times minus 2 times x. So this and this will cancel each other. And then this one is square root of something, but minus power, negative power. So we can place that in the denominator as square root. So 2 minus x squared, and the numerator will be x. And there was minus here, so I will put minus there. So we will use this formula again. So square root of 1 plus differentiation squared. So L equals integration 0 to 1 square root of 1 plus dy over dx squared, which is minus x over square root of 2 minus x squared dx. So that equals 0 to 1 square root of 1 plus, we apply this one to the numerator and denominator. So that is x squared over square root of something squared is 2 minus x squared dx. The next step is we want to think about the common denominator. 1 is 1 over 1, and obviously common denominator is 2 minus x squared. So 2 minus x squared, the numerator is 2 minus x squared plus x squared dx. And so the two cancel each other. So this one is from 0 to 1. So numerator is square root of 2 and denominator is square root of 2 minus x squared dx. So we are coming to the tricky part. So we have to do trigonometric substitution. However, we just use the formula. So 1 over square root of 2 squared minus x squared dx. So in the trigonometric substitution, what we learned was dx over a squared minus x squared equals sine inverse of x over a plus c. So that is the formula we want to use. So that's the reason we converted 2 to some number squared, square root of 2 squared. And then a becomes square root of 2, right? So when we apply this formula here, we have square root of 2 sine inverse of x over a square root of x, square root of 2 here from 0 to 1. And then that is square root of sine inverse of x is 1 over square root of 2 minus sine inverse of 0. We know the graph of sine looks like this. Sine inverse of 0 is 0. And we have to evaluate one sine inverse square root of 2. We consider 45, 45, 90-degree triangle, which looks like this. Identity looks like this. So inverse image of this one. So we are looking for the angle value, which is located between negative pi over 2 to pi over 2, and whose sine value becomes 1 over 2. That is the angle which is located in the first quadrant. And this is opposite. And square root of 2 is hypotenuse. So opposite, that is opposite of pi over 4, and the triangle's hypotenuse is square root of 2. So we will use that fact, then that is square root of 2 times pi over 2. So that is pi square root of 2 over 4. Any question about this? I think trigonometry related background is embedded in course website. So if you have problem in understanding, then you have to study what is embedded in the course website. I made a mistake here because I was saying pi over 4, but I wrote pi over 2. Any other correction or question? Thank you. Yeah, everyone makes mistakes, right? I made a mistake here. The next one is y equals natural log of secant of x. X is from 0 to pi over 3. dy over dx. So of course, we have to differentiate it. So we have to use chain rule because definitely this is a composite function. So we will put u equals secant of x, and then du over dx becomes secant x tangent x. And when we use this expression, this becomes u. So the formula goes like dy over du times du over dx, right? So when we do apply the chain rule, we understand y equals natural log of u. So we consider this part first, and then we multiply by this. So dy over du is 1 over u times du dx is a secant of x times tangent of x. And 1 over u is secant of x. So 1 over secant of x times secant of x times tangent of x. So secant of x will cancel each other. And so that is tangent of x. So that was 1 plus f prime of x, which means f prime of x squared, which means we have to put tangent squared of x and then dx. By the Pythagorean formula, that equals square root of secant square root of x dx. And then we realize that square root of something squared is secant, right? The integration of secant has very special integration. So integration secant of x dx is limit, natural log of secant of x plus tangent of x plus c. So this is the formula which you learned. So I'm sorry, again mistake. You're copying wrong. So pi over 3. So secant of x dx. And then what is this? This one becomes natural log of secant of x plus tangent of x from 0 to pi over 3. So we think about the angle pi over 3. So we think about 30, 60, 90-degree triangle. So we have to evaluate secant of x. Secant of x is 1 over cosine of x. So that becomes hypotenuse over adjacent. So hypotenuse is 2 and adjacent is pi over it is 1. So hypotenuse is 2, adjacent is 1. So that is 2. And we want to calculate tangent of x. Tangent of x is opposite over adjacent. So this is the opposite. And so square root of 3 over adjacent is 1. So that is square root of 3. Let's plug in. Then natural log of secant of x was calculated as 2 plus tangent of x is square root of 3 minus natural log of secant of 0 is 1 plus tangent of 0 is 0. So this part is natural log of 1, so that vanishes. And then we have natural log of 2 plus square root of 3. So any question? Let's do the next question. Hyperbolic cosine and hyperbolic sine is rarely appearing, but if you look at the go through the website problem, then you will encounter. So y is given as 9 plus 1 over 4 hyperbolic cosine 4x. We think about x ranges between 0 and 7. So the first step was calculating the differentiation. So that is 1 over 4 times, we think about the composite function. So that will produce 4 from the derivative of this part. And if you differentiate hyperbolic cosine, then you get hyperbolic sine. So it goes like this. So we eventually end up getting hyperbolic sine of 4x. So the formula, a little bit confusing formula, is a hyperbolic sine of x dx. The differentiation becomes hyperbolic cosine of x. And the hyperbolic cosine of x derivative becomes hyperbolic sine of x. It is quite similar to the sine and cosine functions derivative, but both just exchange each other, but cosine's derivative doesn't become negative sign. I mean, hyperbolic cosine's derivative doesn't become negative hyperbolic sine. It just, there is no negative. So let's do that. Integration 0 to 7 square root of 1 plus, we already calculated this one. So this part sine, hyperbolic sine squared 4x dx. And then integration 0 to 7 square root of hyperbolic cosine square root of 4x dx. So the Pythagorean formula with the sine and cosine goes similar. No, it is actually not Pythagorean formula. It's just a formula which you can verify. So what you can do is this is just an identity. Is if you want to verify, the hyperbolic sine of x is e to the x minus e to the minus x over 2, and hyperbolic cosine is e to the x plus e to the minus x over 2. And then if you just calculate, then you will get this. So integration 0 to 7 hyperbolic cosine of 4x dx. So when you integrate, that is 1 over 4 hyperbolic sine of 4x. Just I have to divide by this number when we do integration, as we have been doing with a substitution. And then we go this way for integration. And so that is from 0 to 7. Let's plug in here. Then 1 over 4 hyperbolic sine of 4 times 7 will make 28 minus 1 over 4 hyperbolic sine of 4 times 0 is 0. Let's plug in 0 here. So hyperbolic sine of 0 equals e to the 0 minus e to the minus 0 over 2. Both are the same number because those are 0 power. So 1 minus 1 will make 0. So entire fraction becomes 0. So this one vanishes. So the final answer is 1 over 4 hyperbolic sine of 28. Any question? Let's do y equals 1 over 2 x squared when p is minus 5, 25 over 2, and q is 5 and 25 over 2. So of course, we will differentiate the given function, then that is 1 over 2, 2x. So that becomes x, right? And then L is from, we're thinking about dx. So minus 5 to 5 square root of 1 plus x squared dx, right? dy squared is x squared. So that becomes 1 squared plus x squared. And then we think about the graphical shape of this function. Then the graphical shape of this one is when x equals 0, then that is 1, square root of 1, which is 1. And then when x gets larger and larger, 1 plus x squared will get larger and larger, and the square root of that number will become bigger and bigger. So right side will look like this. And left side, the same thing happens because x squared make minus sign useless, right? So x and minus x will have the same output value, which means that is symmetric along y-axis. So this is the graph of y equals square root of 1 squared plus x squared. And we are thinking about the integration from -5 to 5. That also means, because that is symmetric with respect to y, left side and right side are the same. So 2 times 0 to 5 square root of 1 squared plus x squared dx. If you want, then you can just use this one as it is. But if a 0 is involved, the calculation becomes easier. So integration square root of a squared plus x squared dx equals x over 2. I'm talking about the formula we will use. So a squared plus x squared plus a squared over 2 natural log of x plus square root of a squared plus x squared plus c. So this is a formula we will apply. And then that is 2 times x over 2 square root of 1 plus x squared plus, because a is 1, right? A is 1. So we just do substitution. So 1 over 2 natural log of x plus square root of 1 plus x squared from 0 to 5. So that is 2 times 5 is plugged in here, 5 over 2 square root of 1 plus 5 squared plus 1 over 2 natural log of 5 plus square root of 1 plus 5 squared minus, let's just go through 0 over 2 square root of 1 plus 0 squared plus 1 over 2 natural log of 0 plus square root of 1 plus 0 squared, and so on. So this part becomes 1, so natural log will vanish, this one vanish. So the final answer will be, we have to, we can ignore this 2 because these 2 and 2 will cancel each other when we do distribution. So the final answer is 5 square root of 26 plus natural log of 5 plus square root of 26. This is 26. Now we want to think about the different pattern. So this time the function is function of y. So x equals g of y. And y is between c and d. And g prime of y is continuous function. Then what we know is L is from C to D. Just the everything is the same, but just the variable switch it, X and Y or switch it. So the same formula goes through. That's what I'm saying. 1 plus G prime of Y squared dy. And of course, that can be written as C to D square root of 1 plus dx over dy squared dy. So essentially the same formula except switching x and y. And so we will do extremely similar problem with a different variable. The problem is find the length of the curve. So x equals y to the fourth power over 8 plus 1 over 4 y squared. Y is from 1 to 2. So as I said, the only differences between the problem pattern is just the everything is same. It is the same, but x and y position are switched. So instead of thinking about dy over dx, we think about the x over dy. So that is 1 over 8 times for this part, that is 4y cubed plus 1 over 4. This can be written as y to the negative 2 power. So minus 2 times y to the negative 3 power. So we do cancellation. This one and this one will cancel each other and make 1 over 2. Y cubed minus this one and this one will cancel each other. So that'll be 1 over 2 y minus cubed. So we will use this, and of course we have to think about dx over dy squared. So let's do it first because we have to do it under the square root. We don't like it. So we have 1/2 as a common factor. So y cubed minus y to the minus cubed squared. So we do 1/4 times y cubed minus y to the minus cubed squared. So that is 1 over 4. And then the formula goes y to the, let's just write y squared minus 2 times first one times the second one. So y cubed times y to the minus 3 power plus y minus 3 power squared. So the formula I'm using is, I believe everybody is familiar. So a minus b squared is a squared minus 2ab plus b squared. So the first thing we can notice is they will eliminate each other, cancel each other, because this is y cubed over y cubed. So that becomes 1. And when we distribute 1/4, 1/4, and this is y to the 6th power, and 1/4 times 2 will make 1/2. So the second one will be 1/2 plus 1/4. I do this, and then y to the minus 6th power, right? So what we are doing is we are trying to calculate what's under the square root. So 1 plus dx over dy squared is 1 over 4 y 6 power. This time it becomes 1 over 2 plus 1 over 4 y to the negative 6 power. So this one, just let's think about this part. So 1 over 4 y to the 6th power can be written as 1 over 2 squared times y cubed squared. So that is 1 over 2 y cubed squared, right? And then the next term, the last term can be reinterpreted as 1 over 2 y to the minus cube squared. In the middle, that can be interpreted as the 1 over 2 times y cubed times y to the negative 3 power, because they will cancel each other. But what we want to think about in this case is we want to think about a plus b squared equals a squared plus 2ab plus b squared. So the way we will understand this part will be just indeed 2 times 1 over 2 y cubed times 1 over 2 y to the negative 3 power. And then what happens here is these two are multiplied together and form the middle part. And then we multiply by 2. This is 2. And then when you go back here, so these two will cancel each other, and 1/2 remains here. And so when we cancel those two, we get 1/2, right? And so all I'm saying is that this can be decomposed into 1 over 2 y cubed plus 1 over 2 y to the negative 3 power squared. Because of that. this one and this one. This is A and this is B. So, sorry, so we are ready to calculate. So L is from 1 to 2 square root of 1 plus dy over dx squared dy. And then 1 to 2. So we went through the calculation, and then this is square root of 1 over 2 y cubed plus 1 over 2 y to the negative 3 power squared dy. So do the square root and squared will cancel each other. And then the remaining thing is integration 1 to 2, 1 over 2 y cubed plus 1 over 2 y to the negative 3 power dy. So we do term by term integration. So 1 over 2 y to the 4th power over 4 plus 1 over 2 y to the negative 2 power over negative 2. We just add 1 to the power and divide by the same one. So we are doing from 1 to 2. So that becomes 1 over 8. We multiply these 2. And y is 2 to the 4th power minus 1 over 4. Just so we are combining these 2, get minus 4. So negative 1 over 4. And then y to the negative 2 power. So that becomes 1 over 4 minus, open parenthesis, 1 over 8. We are going to here times 1 to the 4th power minus 1 over 4 times this one, 1 over 1 squared. So that is what this is, 16. So this is 2. So 2 minus 1 over 4 times 1 over 4 is 16. Minus, open parenthesis, 1 over 4, 1 over 8 minus 1 over 4. And then all we have to do is just simplification. This one is 32 over 16. And so when we combine these two, we will get 31 over 16 minus, we just a distribution, then negative 1 over 8 plus 1 over 4. And so negative 1 over 8 plus 1 over 4 is negative 1 over 8 plus 2 over 8, which is 1 over 8. So this part is 1 over 8, right? 31 over 16 plus 1 over 8. The common denominator is 16, so 31 over 16 plus 2 over 16, which is 33 over 16. So we got the answer eventually. It is pretty mechanical process. The only tricky part here is from here to here. So this part, understanding this one as something squared might not come to you easily. So you have to know how to see this expression when you solve the problem. So that is something squared because of the reason I explained here. Any question? Okay, and then today is Thursday, right? And then we will see on Monday. Yeah, so we'll see Monday in Math Science building. Okay, see you on Monday.